Hello and welcome to another Portworx demo. In this demonstration, we are going to talk about how Portworx Backup allows you to protect your virtual machines that are running on top of your Kubernetes cluster, either using the KubeVirt project, or in the case of this demonstration, we have installed a Red Hat OpenShift service on AWS or ROSA cluster and enabled the OpenShift Virtualization feature. To deploy a couple of different virtual machines, we have created a new project or a new namespace called PX Barbecue, and we have installed a couple of CentOS based virtual machines using the OpenShift Virtualization catalog. One of these VMs has MongoDB running on it with a root disk, and the second virtual machine has Postgres installed on it. And in addition to the root disk, we also have a data disk that is used by Postgres to write data. All of these persistent volumes are backed by Portworx Enterprise running on top of your ROSA cluster. So now that we have looked at the two virtual machines that we have installed, let's go to Portworx Backup and verify and configure a couple of additional things. So as you can already see, we have added our ROSA cluster to our Portworx Backup dashboard. And then we have already added our AWS account and an S3 backed backup location. We're just using a non-object lock enabled backup location, but you can also use an object lock enabled S3 bucket or an NFS share to store your VM based backups. Now that we have our cloud accounts and backup locations configured, let's go ahead and configure a new schedule policy. This schedule policy will allow us to create a backup job with periodic hourly backups for our virtual machines running in the PX Barbecue namespace. So you can configure a new periodic policy, give it a name, and select the interval that you want. And you can also change the retain and incremental count. We'll keep it simple, 1 hour, and leave the retain policies to default. We'll also create a couple of pre and post backup rules, and these are important because you don't want your virtual machines to be crash consistent when you take those backups. You want them to be file system consistent. So Portworx Backup allows you to extend the Virt freezer utility and create these pre and post backup rules and point it to your specific virtual machines running on OpenShift, so that before the backup is taken, it freezes everything. It freezes the virtual machines that you have in that namespace and then takes a backup snapshot. So for this step, you have to make sure that you also have the QMU agent running on your virtual machine, because that's what the Virt freezer utility depends on. We've already taken care of that before this step. So we created the freeze rule. Now let's create the unfreeze rule. So we have to specify the label that's assigned to both of our virtual machines. So in our case, it's app equal to MongoDB and app equal to Postgres VM. Both of those are virtual machine names. And then our actual Virt freezer command, where we gave it the freeze command. Now we're giving it the unfreeze command and pointing it to the right VM running in that namespace. Once you have configured the freeze and unfreeze rules for your virtual machine based backups, the next step is to just create a simple backup using the same workflow that you use today if you're using Portworx Backup. Let's find the PX Barbecue namespace on our OpenShift cluster. Select that namespace, and Portworx Backup allows you to customize the way you take backups, right? You can specifically select the CRDs or resources that you want to backup. So you can just select virtual machines, virtual machine instance type, and only back those objects or those custom resources. But in our case, we want to back up not just the VMs, but everything that's running in that namespace. And that includes the persistent volume objects, the secrets, the service objects. So let's select all resources and hit the backup button. Once you hit the backup button, Portworx Backup will ask you for a name. So let's give it a name for our scheduled backup. So PX Barbecue VM Backup, that will be the prefix that's used whenever an instance of that backup, scheduled backup is created. Let's select the hourly VM policy and the backup location correctly. Again, and then finally, let's select the pre-exec and post-exec rules. These are the freeze and unfreeze rules that we created earlier in this demonstration. This allows us to create those file system consistent backups. Once you select everything and everything looks good, you can hit the create button, which basically initiates the VM-based backup or the backup of your entire namespace running on your ROSA cluster. It takes all the objects, including virtual machines, persistent volume claims, secrets, and saves it to that S3 backed backup location that you have mapped to Portworx Backup. You can also monitor the backups using this backup timeline feature, where you can get a view of the last 24 hours, or you can also zoom out and get a last 30-day views. We'll quickly wait for this backup to be successfully completed. So it goes through and protects the root disks for MongoDB and Postgres, and also protects the data disk for our Postgres VM. So it starts by protecting the persistent volume claims first, and once that's done, it backs up all the Kubernetes or OpenShift resources. Once you have created a successful backup, you can actually look at more details and see what resources are protected. So let's do that. Let's create and let's look at the show details feature or widget. Here you can see the backup name, backup location, the size of the backup, the resources that were protected. So as you can see, we have 3 persistent volumes that have been backed up. We have a few cluster roles. We have persistent volume claims, a couple of virtual machine objects. We have pod disruption budgets, config map, and service objects, everything included in that backup. So it took a backup of our entire namespace. Now that we have a successful backup, let's go ahead and delete the virtual machine objects. But before we do that, let's look at all the resources from a CLI perspective as well. So if we do a kubectl get all in the px barbecue namespace, you can see the couple of Virt launcher pods that we have, couple of virtual machines, service objects, and then the virtual machine instance resource as well. So we see all the resources now. Let's go ahead and delete the virtual machine so that we get rid of all of these resources so that we can perform a restore operation. So let's go to the OpenShift web console, hit delete on our MongoDB VM, and then also hit delete on our Postgres VM. Once both of these VMs are deleted, we can then go ahead and perform restore operations. So again, this takes a couple of minutes for the VMs to be actually deleted, because it's not just deleting the VM objects, but also the persistent volume claims and the Virt launcher pods as well. So now that we don't have our VMs anymore, let's go back to Portworx Backup, select the backup snapshot from which we want to perform the restore operation, and then hit restore. We can give the restore object a name. So we'll just call it VM-restore, and then we select the Rosa cluster as our destination cluster. You can also restore to a different OpenShift cluster if you wanted to. You can customize the way the restore happens. So you can restore it to a different namespace using a different storage class, but we'll just keep it as default for this simple demo. Once you hit restore, it initiates the resource process, and similar to backup, it starts with the volumes because they take the longest time. And then once the volumes are successfully redeployed, it creates the remaining OpenShift or Kubernetes resources as well. So this will take anywhere between 2 to 10 minutes, because it depends on the size of the objects that you are restoring. As you can see, our virtual machine objects, or the restore job has been successfully completed. If we go back to the OpenShift console, you can see our MongoDB VM back up and running 0 minutes ago. So it's just a few seconds. We were able to catch it in time. With you can see our root disk has been restored. And then if we go back to the virtual machine summary page, we can also see that the Postgres VM has been restored as well. And the Postgres VM, in addition to the root disk, we also had a data disk. Both of those disks have been successfully restored. Let's also go to the CLI and verify that the restore operation worked as expected. So we'll do a kubectl get all in the px barbecue namespace. And as you can see, 59 seconds ago, we have the Virt launcher pods and virtual machine instances created and virtual machine objects created. If you look at get PVC, you can see all 3 persistent volumes restored 73 seconds back. So all of our resources in that namespace that belong to the virtual machine have been restored successfully. That's it for this demo. Thank you for watching.